today, we're talking about systems of equations, but instead of using the substitution method, we're going to use something called the elimination method. Now, the only difference really is the very first step. But it's going to look a little bit different after that too. And I'll show you why. So let's say we had two equations, like x minus y equals 0, x plus y equals 8. Let's say those are my two equations. I don't have, at least not right away, an x equals or a y equals. Now, I could add y to both sides of this equation and solve it using the substitution method that way. I would have x equals y, and I could plug the y in for x here, and then I could solve that. That would work. But there's another way to do this. And this is what we mean by elimination. I can actually add these two equations together to make one equation. So I can add this side of this equation, and I can add this side of this equation plus this side of this equation, and then I can add this side plus this side, and I will get one equation that I can solve.
But how do we get 8 again, though?
I gave you this.
Oh, okay.
This is your system of equations. You have two equations, two variables. Right? The first step here, to use the elimination method, you're going to add x plus x, which is 2x. Then this is the key. Negative y plus y, that's 0. So one of the variables actually drops out. And that has to happen for this to work. 0 plus 8, which is 8. Now I can solve this. 2x equals 8. I'm going to divide both sides by 2. And I find that x would equal 4. To find y, it's the same procedure as before, except we don't already have an equation that says y equals. So what I have to do is I have to take my x, and I can plug it into either one of these equations. Doesn't matter which one. Let's do the second equation here because there's no negatives. So if x is 4, then this equation tells me that 4 plus y equals 8. Because I know that x is 4. So I put 4 where the x was. So 4 plus y equals 8. Subtract 4 from both sides. And I know that y must also equal 4. So my ordered pair is 4, 4. These two lines would intersect on a graph at the point 4, 4 over in the first quadrant.
Okay. I think I understand. Okay.
Which is easier?
It's easier if it's set up correctly. And all of them today are going to be set up correctly.
Okay, I thought you were trick us.
No.
Does this get any harder?
Yes.
Well, you definitely get some hard stuff too.
Let's get a little harder. Okay. Alright, let's say we had something like this. And this one's on your homework. So when you get to it on your homework, hopefully you'll remember to check it. It's number 2. Okay. 5x plus 3y equals 21. Negative 5x plus 4y equals negative 7. We have here a what? System of equations. We have two equations, two variables. We can solve it. All right. So like I said, for today, everything's already going to be set up. All you need to do is add the two equations together as your first step. So 5x plus a negative 5x, that's just going to be 0, right? So that drops out. 3y plus 4y is
7.
7y. And 21 minus 7. Right? Plus a negative 7. So 21 minus 7 is 14. Simple. Just divide both sides by 7. And y equals 2. But how do I find x?
You would plug in y.
Yeah, we have to plug in this 2. Let's choose the equation that has no negatives in it, which is this one, since there is an equation in it. So I'm going to put a 2 in for the y. So I'm simply going to rewrite this equation. 5x plus 3. But instead of y, I'm going to write a 2. Because y is 2. I already found that y is 2. So now I have to solve this. 5x plus 6 equals 21. Subtract 6 from both sides. 5x equals 21 minus 6 is 15. Divide both sides by 5. And x will equal 3. So our final answer is 3 comma 2. Now I would recommend that you then take the second equation, the one that you didn't already plug into, and you plug this point in and see if it works. So this would say negative 5. So here's to check. Negative 5 times x. But what is x? According to my solution, what do I think x is?
Oh, 2.
3 plus 4 times y, but what do I think y is? 2. Should equal negative 7. Let's see if that's true. So negative 5 times 3 would be negative 15, plus 4 times 2 would be positive 8. Negative 15 plus 8 equals negative 7. Is that true? Yeah. Negative 15 plus 8 is going to be negative 7. So this is true. This checks. And so then I'm confident in my answer. And I want you to take the time to check your answers. Take the time to check your answers. How do I check? I plug in my point after I have my answer. I plug that in to the second equation that I haven't used yet. So in this problem, I already used this equation. To check my answer, I'm going to use this equation. Questions about this?
No. Actually, is that like the exact same thing, but adding numbers, right?
It's the same type of problem, but instead of substituting, we're just adding the equations together.
Right.
Yeah, good question. It doesn't, you could still use substitution here, but it's just harder because I don't already have y equals something.
What is substitution even used for these days, though?
Oh my.
Why would we have to?
Substitution was the first method that we used to solve a system of equations.
How?
Substitution was the first method that we used to solve a system of equations.
What would we use it for?
You would use it to solve. So if I gave you a system of equations like this, y equals 5 and x plus y equals 8, and I said solve this however you want to, you're going to want to solve it using substitution.
I know, but would you like to use it in construction? Like, how would you use it in that?
Okay, you said it
Oh, like in
doesn't
real
matter.
life, how would you use something like
Real
this?
life.
So systems of equations are looking for the point where two lines intersect. Right? That's what we're trying to find. We're trying to find the solution where this is equal to this. And there's a lot of cases where you're trying to find something similar. In economics, right? You want to find where the supply curve intersects with the demand curve. So you find out how much you need to make of a certain product. Okay. So that would be an example of like an economic system of equations. Where does my supply intersect my demand? That'll tell me how many, computers I need to make and what price to sell them.
Right.
There's other things, like scientific applications where you might want to find like literally the point where two things would intersect. So if you're studying motion of objects or sending something into space, you may need to solve a system of equations to figure out that exact point when it's going to intersect. So like if I had an equation that told me about the orbit of Pluto, right? And I had another equation that told me about a space, what's the word I'm looking for? Like a space probe that I'm launching into space, right? So one equation is telling me Pluto's orbiting like this. Another equation is telling me I'm going to launch my probe like this, right? My little rocket ship or whatever. I could solve some sort of a system of equations that would tell me when do I need to launch this so that the probe actually gets to Pluto.
Oh, right.
Right? When would they actually intersect? So that'd be another kind of example or something. Yeah.
Aren't they sending a little thing?
I'm going to turn off the video because I think we're done with questions specifically about elimination.
Okay.
Is that correct?
Yeah.